guys, I'm going to do this extra review in case you need it, okay? So question 1, rational or irrational? You can really use your calculator if you're not sure, but anytime you have a perfect square under a radical, it's going to be rational. So like this is going to equal 15, and 15 is a counting number, and all counting numbers are rational. Anytime you have a not perfect square, it's going to be irrational. So 200 is not a perfect square, so this is going to be irrational. Okay, and this is going to be rational. Like I said, you can also use your calculator to help. So let me just try to pull up my calculator for you. On your calculator, if you get a terminating decimal or you get a whole number, then you can tell that it's definitely rational. So second square root 225, 15 rational. Second square root 200, enter. That's a non-terminating, non-repeating decimal, therefore it is irrational. So again, you can use your calculator. Oh boy, I hope I didn't lose that screen. Here it is. Okay. What could be the equation of the quadratic? So basically, it's right side up. So we know that a is positive. And if you look from the turning point to the next integer point, it's got a average rate of change of 1. So I know that a equals 1. And then I can also look for the c, which is the y-intercept, and that's going to be -3. On multiple choice, sometimes knowing just that would be enough to pick it out amongst the choices. If that's not enough, you can always use your graphing calculator to match and look at the calculator, look at the picture, or you can also use the roots. So since the root here is -1, I know that inside the parentheses is going to be x plus 1. Since the root over here is +3, I know that inside the parentheses is going to be x minus 3. So you can also use the roots. All right. And then again, use your graphing calculator to double check and make sure you're right. Okay. If I multiplied this out, I would get x squared minus 2x minus 3, which does confirm my y-intercept. Okay. All right. Standard form to vertex form. So this is basically completing the square. So I'm going to move the 38. And remember, inverse operations move things. And now the idea is that you want a perfect square trinomial. So I'm looking at the -12. The -12, half of -12 is -6. So I know that in here is going to be x minus 6 squared. But I need to do the -6 squared and get the 36 so that I know what to add to both sides. So that gives me y minus 2 equals x squared minus x minus 6 squared. So I just have to move that 2 back. So I get y equals x minus 6 squared, add 2. And that's because the opposite of subtracting, which is shown here, is adding. Okay. What transformation occurred? It's definitely a flip, which means a is negative. Okay, right side up to upside down, that means the a is negative. It's definitely a flip, or you can use the words reflection over the x-axis. It doesn't look like, because like this is 1 and this is 1, this is 1 and this is 1. So it doesn't look like there was a stretch, which would make it, narrower, or a shrink, which would make it wider. I prefer the words narrower and wider. I just think they're easier to understand. So remember that if, like, say a equals 2, that would be narrower. If a equals a half, that would be wider. And just keep that in mind. Okay? So I would call that a flip or reflection over the x-axis. Okay. Quadratic function f of x is shown in the table below for integer values from 1 to 6. What is the value of f of x when x is 1? So really, I'm just looking for this symmetry. 2 has its partner of 2. So that means that this right here, 3 comma 4, is the turning point. So 1, 2, 4, 5. So this has to be -4. Because they're kind of like partner pairs. All right. So like this one has symmetry with this one. Okay? Partner pairs, symmetry, however you want to think of it. All right. Find the turning point, find the range. So I could use vertex form to find the turning point, or I could just use my calculator. With vertex form, it would be x minus 3 squared. I get the minus 3 because I take the negative 6 and divide it by 2. When I do that, I have to add 9 to both sides. So that would give me y plus 2 equals x minus 3 squared. And then you move the 2 back. So that would be y equals x minus 3 squared minus 2, which means the turning point is 3 comma negative 2. But I can also use my calculator. Remember, the calculator is always there. It's really, really important to just, use it when you can. So if I type, this is kind of all messed up, so I'm just going to hit clear here, and I'm going to type in here instead of wasting your time changing it. So minus 6x plus 7. I mean, it's not really messed up. It's just that it's an inequality. All right, so when I hit graph, this would be the turning point, 1, 2, 3, comma, negative 2. Okay, and you can also see that on the table. Right here, 3 comma negative 2. Let me change my table set because I know that annoys some of you. Here we go. So right here, 3 comma negative 2. And you can tell because it has the symmetry. Okay? So you can look at the graph. You can look at the table. And you can also do vertex form. Vertex form is very useful. Okay, find the range. So remember, it goes down to negative 2. It stops, it turns, it goes up. So we would say y is greater than or equal to negative 2. You can also write that in interval notation like so. Okay? All right. When would a quadratic have the same zeros as another? It's basically when there's a dilation. So for example, I would be able to factor this, and I would have x minus 7 and x plus 1, right? So that means that the zeros are 7 and negative 1. Those are my zeros. So if I stuck a 2 in front of this, I dilated it, it wouldn't change the zeros, okay? If I stuck a 0.2, a decimal 0.2 in front of that, it wouldn't change the zeros. So it's basically if the A changes and it's still the same factors, it's going to have the same zeros. If you have the same factors, you have the same zeros. And you can also look at that on the graphing calculator, once again, my friend. So let's just say I have this, okay? If I was to dilate it, that would mean that I multiply everything by like 2, 3, 4, whatever number I choose. So I'm going to multiply everything by 2. 2x squared. Wow, I didn't mean to hit log. 2x squared minus 12, because 6 times 2 is 12, plus 14. All I did was dilate. I multiplied everything by 2. And I hit the word graph, and you see it has the same zeros. Not the same parabola, not the same equation, but the same zeros. And you can play with that. Also, if you don't remember that, you just have to use your graphing calculator. Okay, how can you determine the number of roots? The number of roots is equal to the number of x-intercepts, which is also known as the roots. Okay, so when you look at the picture that we just had, there are 2 roots, 2 roots. There can be no roots, 1 root, or 2 roots. Just look at the picture. You can also use the discriminant. That's the b squared minus 4ac. And then you can analyze what that is based upon, like if it's negative, if b squared minus 4ac is negative, that means that there are no real roots because that's imaginary numbers. Okay? So you can always look at the b squared minus 4ac, which is on the reference sheet. It's just not like circled. it's part of the quadratic formula. Okay. So the turning point is 3 comma neg4, which means this is going to be a partner point, and this is going to be a partner point. There's always symmetry around or about the turning point because it goes down, it comes up, or it goes up and comes down. All right, complete the chart, done, find the zeros. Okay, so the zeros, you always go backwards from 0. So the zeros are 1, oh my gosh, that's the worst looking brace, and 5. Here's going to be a better brace for you. Okay? Any questions? Oh, you're not really there, but I am here. So if you do have questions, you can always email me because I do check my email. As I've said before, I go to bed kind of early, but you can always email me. Okay, so if they're both set equal to y, you can easily set them both equal to each other. So like if this equals y and that equals y, this equals that. So I'm going to move this over. The opposite of adding is subtracting. The opposite of adding is subtracting. So that gives me x squared subtracting 9x plus 8 equals 0. I am going to factor this because I can. So when it comes to solving a quadratic, you have 3 choices under the algebra way. Okay, you have graphically or algebraically. So you have 2 big choices, and then under algebraically, you can factor, you can complete the square, or you can use the quadratic formula. You pick. It doesn't matter. So you get x equals 8 and x equals 1. But remember, these are the x values, and they need y values. So it's 8 comma somebody, and y comma somebody. Okay. So 8 plus 4, I'm going right here to the linear, is 12, and 1 plus 4 is 5. Okay. All right. The quadratic is shown below. Determine the roots. And okay, all that stuff. All right, so I'm going to start with the roots. The roots are second chance to draw a brace. -2, 1, 2, 3, 4, and 4. Okay, so those are the roots. Factored form is always the opposite, so it's x plus 2 and x subtract 4. Now, I do need to double check to make sure that my a equals 1, and it does. So I'm looking at my vertex, and I'm going over. Okay, standard form. Just do the multiplication, okay? Some of you like the box method. So like you would be like x plus 2, x subtract 4. X times x, x times 2, x times -4, -4 times 2, which gives me y equals, you could keep the 0 there or the y. The y is probably better, so I'm going to like cross that out and put a y. Okay, so it's x squared minus 2x minus 8. Put it all in the graphing calculator. Everything can go in the graphing calculator to check. Okay. All right, so the height of a cannonball is modeled by the function. All right, so this is what would go into my calculator. Oh, by the way, like the one that I did algebraically here, you could also do graphically and check it in your calculator. All right, here, that's what's going to go in my calculator. But before it goes in my calculator, I can do a lot of this work. The initial height is always when time is 0. So that's the y-intercept. So it's going to be 12, and there's the word feet. But you can use your calculator to double check. All right, so I'm going to pull up my calculator. I know I got some weird stuff going on in here, but there's no shame in my game. I don't mind that it's weird. I do fool around with it a lot. I like it. Okay, so I've got the -16x squared, adding 160x, adding 12. You know, the picture's going to look a little weird because I have this 4-quadrant thing going on. So I'm going to change my window. And I'm going to start, well, I went to change the table. That's so silly. I'm going to change my window. So I'm going to start my x at -1 just to have like a little space. And I'm going to keep the 10. But my y, I'm going to do the -1 just to have a little space. Technically, they're both 0, but I just want to have a little space. And there's 160. So 160 is kind of like a big number. So I'm going to go with 100. I can always change it back. Yeah, see, it goes way out past 100. So I'm going to change that again. And I'm going to go to 300. And I'm going to count by tens because that's kind of silly to count by ones. Wow, even 300 isn't big enough, but at least I have a good idea of what it looks like. Okay, so it goes up, it comes down. Now I know this looks like it goes through 0, 0, but that's just because it's a really high scale. Look at the table. Okay, here it starts at 0, 12, and it goes up to 412. Okay. All right, so here we go. Algebraically, now I do know the vertex is 412, so I'm just gonna, not 412. What was there? It was 412 feet. That's not the vertex. Hold on a second. 412. Okay, so I do know the vertex is 412. Okay, algebraically determine how long it takes the cannonball to reach max height. That's going to be the x value of the vertex. So I'm going to use x is equal to negative b over 2a. X is equal to negative 160 over 2 times negative 32. So x equals 5, which checks out. So we're going to say 5 seconds. Algebraically determine the maximum height. That is so super easy because I know the time. So all I have to do is plug in a 5. I know it seems like that's like a crazy question, but just plug in a 5 because I already know the time. And you can use your calculator. You don't have to do that in your head. Just use your calculator. But I already know it's 412 because it kind of checks out. All right. If you don't get 412 and the vertex is 412, you really need to go back and check your math. Okay. So the nearest 10th, that's a hint that it's not factorable. How long will it take for the ball to reach the ground? I'm going to use the quadratic formula. Okay. So A equals B equals C equals. All right. So A equals negative 16, B equals 160, and C equals 12. X is equal to negative B plus or minus square root B squared minus 4AC all over 2A. You can copy it from the reference sheet. So the negative of 160 plus or minus the square root of 160 squared minus 4. A is negative 16 and B is 12. Just a 12. I almost wrote negative 12. That says 12. All over 2 times negative 16. This is totally going to be a calculator deal. All right, so x is equal to negative 160 plus or minus the square root of, that's going to be a big number, and that's negative 32. All right, so I'm going to type that in my calculator. Okay, so parentheses 160 squared minus 4 parentheses negative 16 parentheses 12. That's the discriminant, and it's a big number. It's 26,368. 26,368. Okay, now I'm going to go to my calculator. There is going to be one positive answer and one negative answer, but the negative answer wouldn't make sense because it is time. Time is not negative. So I'm going to go to my calculator. Here it is. So I'm going to do alpha y equals to get a fraction. And I'm typing in negative 160. Oops, I hit the word on. That's so funny. Negative 160 minus second square root 26368 over negative 32. So that's 10.07444,578, and it says round to the nearest tenth, so I'm going to say 10.1. Okay, there is a negative answer, but it wouldn't make sense because it's time. Okay, happy studying.